Okay, I want to welcome everybody to the 2024 Great Lakes Renewable Energy Association Solar Home Tour. My name is John Freeman. I'm the Executive Director of GLREA, and normally this would be hosted by John Sarver, but he has a conflict tonight, so he asked me to be the host. We do this solar home tour every year. We always do it in October because we are the Michigan chapter of the American Solar Energy Society, or ASIS. And every October, ASIS does a national solar home tour as an educational program to help share with people who may be interested in getting solar, to learn from people that have already obtained solar and gone through the process so they can share their lessons with other people who may be contemplating getting solar. So that's why we hold these solar home tours. We're doing it obviously virtually. We have four presentations tonight. We first of all have Diane Van Buren, who is a board member on GLREA. She's very active in Detroit, and she actually owns her own solar company, so she is fully in the business. Michael Hagan will be our second presenter. Michael is from Ann Arbor, and he's got almost, if not a zero net energy home. So that will be very interested. David Arnosti is from the Lansing area, professor from Michigan State University. He's been very active with GLREA for the last several years, and he's always willing to share his wisdom. And then finally, we have Harvey Bell, who is also has a net positive home, and he will be our fourth and final presenter. So we're going to have each presenter speak for about 10 minutes or so, a little flexibility here and there, and then we'll take questions, and then at the end of the program, we'll take questions as well. I do want to recognize our sponsors for the program. We have the Michigan Department of Environmental, Great Lakes, and Energy, otherwise known as EGLE. And then we also have Homeland Solar out of Ann Arbor, Harvest Solar, whose headquarters is in the Jackson area, and then finally Serenergy, who works out of Novi. So we want to thank our sponsors. So with that, I'm going to turn it over immediately to Diane Van Buren for our first presentation. Thank you.
Thank you. And I think I'm going to get this all done.
Perfect.
Is it good?
Yes, perfect.
Okay. Hi, everybody. Diane Van Buren calling in from Detroit. And the sun is going down, as you can see out the window. So we are having shorter and shorter days, and all our solar people are feeling sad about that, aren't we? But my job tonight is to share with you my own experience, which I don't often talk about. I also host the GLREA Detroit Solar Stories once a month on the third Thursday. So tonight's my night anyway. So what we're going to be looking at is how getting a solar project done in Detroit in a historic district has some of its own unique challenges. We all want to have as much solar as we possibly can, but sometimes we have restrictions. So what I learned through my experience, which was 2.5 years ago now, is that the design controls, number one, when you are in a historic district, it's not just your decision, but it's the whole city's decision, with the historic district commission getting involved with what's appropriate for your building. So we'll talk a little bit about that. Another concern is the adequate rooftop. Even though we have very large homes in this historic district, there's lots of gables and lots of south facing, east, west, all in the same house. So we'll see a little bit of that. We're a city of very mature trees. We did have the Dutch elm disease back in the 60s, but since then, all the trees have grown back. We sometimes struggle with the city of Detroit permitting. We'll talk just a minute about that. And then lastly, the DTE connection. So here's a view of what some of the homes in historic Indian Village, and all of you with your solar experience. The first one I'm looking at here, you can see lots of roof, but look at the angle of those roofs, or which ones have enough rooftop facing. You can see all the trees, lots of different types of roofs in this area. And it's a home, it's a district of 300 homes, but each one is totally different. And that's the way it was designed. Every home in this district was a unique design. So looking at an example, this is my neighbor right across the street. The street orientation is usually east or west facing to the street. So this is an east facing home. The front of the house is totally clear of trees, but the city permitting process or the Historic District Commission guidelines said, no, you cannot have solar panels on a street facing. You cannot alter the way that the historic building looks from the street, such as you wouldn't be able to put gables up there either. You wouldn't be able to put any kind of alteration on the front of your house. So their solution was to put them on the back of the house, which was acceptable. The problem is they're shaded pretty much all summer long. So in my conversations with them, you could see even on the little porch on the back, there's some panels there. They've really tried to squeeze in panels wherever they could, but their electric bill really isn't greatly impacted because of the shade that they have. What they like to think is that when they turn on the air conditioning in the summer, a little bit of the solar takes care of that for them. Well, I'm right across the street. So this is me with that big oak tree right in front. This is what was approved, by the way, and that's a drone. So it's kind of hard to see, but you can see how much they were able to get done. So here I am with a giant oak tree out front. 2.5 years ago, there was a GREA solar program offered through Wayne County and the Michigan, or no, the great, what is it? MREA, Midwest Renewable Energy Association. So I tagged on with that to see how their program was going to work, knowing full well that I would have the same restrictions as my neighbor across the street. So my west-facing roof, of course, was not eligible. And there's a big oak tree there anyway, so we weren't going to go in that direction. But I do have a garage, which earlier you could actually see out the window in my screen here of me talking, but it's now gone dark, so we can't see it anymore. So with a little bit of tree trimming, the garage seemed like it might be the best solution. Now, not a lot of space on the garage, so I was able to get about 5.5 kilowatts on the garage. That was about it. So here's my summary. We started with 4 kilowatts, but we decided we'd bump it up a little bit more. And that would generate about 65% of my energy from solar. Now, we all know that the ideal situation doesn't always work out with what they say you're going to be able to get, but it has pretty much proven out. So here you can see my granddaughter, but you can also see the system that we put in, with the garage being covered, literally covered with as many solar panels as we could possibly fit. But I decided also that being in Detroit with a lot of energy or DTE outages, that we would go ahead and put in a 9.5 kilowatt battery system through Enphase. And that was probably the smartest decision I made. There have been times, even in February, when the neighborhood has zero power, but we're able to produce enough electricity from our solar panels to feed our batteries that we're able to stay on, even in the dead of winter. So it's quite a nice integrated system between the panels and the battery, and kind of easy to do. The city permitting process was a little bit rough. The Enphase system has the slightest delay, and actually it was DTE's permitting or connection to slightest delay with the shutoff, that they were concerned that it wasn't fast enough, but we got ours through. So here's my 2-year summary as of today. We've had a sunnier year this year than last year. I don't know what everyone else's experience is, because here it is October and I'm almost equal with what I had in 2023. In the summertime, I don't have air conditioning, number one. So that's one of the ways that I save the most electricity, is by not burning it. But these houses were designed to have airflow, so I decided I would just go with that. But you can see how much I imported was, and this is total for 2 years and a few months, 7.2 megawatt hours imported compared to 9.2 that our solar panels have produced in this amount of time. Of that, I've been able to export. After the batteries are filled, I'm still exporting 2.6 megawatt hours over those 2 years. And right now, my electric bill is still pretty much zero, other than the charge, because I'm still using my backup bank that was produced over the summertime. And then you can see how much the green is how much the battery has been able to keep us going. Another important part of the battery, two important parts of battery, is that one, if the power goes down, of course, you stay on because you have a battery and you don't have to shut off. But number two, you get to fill that battery at night if you want, when the rates are cheaper. And right now in DTE territory, the prime rate is at 22 cents a kilowatt. So I'm able to fill it at night, fill my battery at night when it's much cheaper, and then run off the battery during those prime hours between 3 o'clock and 7 o'clock. So saved a lot of trees, or CO2, 6.6 tons. So that's my summary. And I think I got my 10 minutes in. And I can take any questions if you have them.
Does anybody have a quick question or quick questions for Diane?
I do. Harvey here. Diane, have you ever had a power outage that you used your batteries for?
Oh, absolutely. As I said, in February last year, we had 3 days of power outage completely, and I was fine with power because the solar during the day, even though it was February, was still enough to feed the batteries. You unplug everything you can unplug, of course, but it did keep us going for the 3 days.
So you selectively chose what would be powered.
Yes, no, I mean, it's just, you don't turn on things like all the lights in the house. So I just basically had the furnace and the refrigerator and the basics. I didn't.
Yeah, that's what I meant.
Yeah,
Thank you.
yeah, right.
Diane, can you unshare your screen, please? And then we have a quick question from Kenneth in the chat. Kenneth, you want to articulate it out loud?
Okay, sure. So the question is in Michigan, do we have better power coming in from the sun in the winter or better in the summer? You can define better any way you want, but I'm kind of curious.
The winter time solar panels are going to work better because they actually work better in colder weather versus hot weather. And in May, that's why we always have the highest production, is because the air's clear, it's not humid, it's not hot. So we just don't have many hours. That's all. So it's the production is just so severely dropped. My worst month is October because the sun is low and there is a giant bank of trees in my neighbor's yard. And so I just don't get much in October. But once those leaves finally come down, I'll be back in production.
The only other question I have as a follow-up is, I don't know if anyone here has it, but maybe they'll show. There's those panels that kind of can sit perpendicular to the ground, I guess is how to put it. And so supposedly the sun is at a lower angle, you get more on those. And they don't
As
have to be
long
on a
as you
roof.
don't have trees in the way.
Oh, yeah, that too.
I have a lot of trees and my next door neighbor has a lot of trees and they're very big mature trees. So I don't start producing now until, because the sun is low enough that they have to clear all those trees going to the southwest. And by 2 o'clock, I finally start producing. And when the sun's down at 6:30, I just don't produce. Once the leaves are off the trees, I'll start producing again.
Okay, we need to switch now to.
Thank you, everybody.
Thank you, Diane. We need to switch to Michael Hagan. Michael, it's all yours.
Do I click share?
Harvey, I think so.
Yeah, you go ahead and hit share, Michael.
There you go.
Pick the one you want.
Okay. So I'm Michael Hagan. I'm in Ann Arbor. And I'm going to talk about my net zero home. So this is my home. It's an ordinary home and nothing special about it. There were no energy things when it was built, and everything I've done to it has been retrofitted. So the first thing I did was an energy audit so that I could find all the leaks. I fixed all the leaks with insulation around the windows and the doors. I did rim joist insulation all around the whole house, which made a huge difference. First piece of equipment I got was this energy recovery ventilator. So this takes air from the outside and air from the inside, and it runs them side by side. And the energy transfers between the two streams. So like today, if my house is 70 and it's cold outside, if it was like, 50, this brings the air in and the energy makes it so that the fresh air coming in, it's no longer 50, it's more like 60. So it's like halfway where it needs to be. So I have all my appliances are electric. So this is my clothes washer dryer and my electric oven. And I converted to an electric water heater. And then I got a solar. So my solar system is a 9.6 kilowatt system, 27 solar panels. My house is not ideal. My roof faces east and west. So I have 24 panels facing on the east. I do have an addition and I put 3 panels facing south. And these panels have a microinverter on each panel. So my roof is like those in Indian Village. It's not a solid roof, so it's in sections. So this is one section facing east. This is another section facing east. And this is a third section facing east. And then this is my sunroom I built on, and then I put 3 solar panels on top of that. So this is the aerial schematic of what those 27 panels look like. Now, I also got 2 Tesla Powerwall batteries, storage batteries. They can hold 27 kilowatts. My house uses, on average, between 8 and 9 kilowatts a day. And so this can power me during a power outage for 3 days. It also has a system built into it that if the Weather Channel is predicting a storm, it will charge up the battery to 100%. So that the battery is available for power when the power goes out. And that's happened a couple of times. I don't know about everybody else, but we get a lot of power outages in Ann Arbor. And this is my heat pump. So the outdoor compressors and the indoor air handler. This is a Mitsubishi. It's the largest one that they make for residential homes. It works until about 0 or 5 below 0, It will continue working below that temperature, but not at 100% efficiency. So I do have a backup that I don't like to use, but up in this region here is two metal strips, power strips. And if I needed to supplement what the heat pump is doing, I can turn on those electric strips, and then they will get hot and create warm air as well. And I also have an electric car and a car charger in my garage. And this is my house. It's now net zero. I produce no greenhouse gas emissions because I burn no gas. There was a picture there that I showed that you could see the empty gas pipe coming down. So I have no gas. It was a good day when I called DTE and canceled my gas line. And then as far as electric goes, I produce more electricity in a year than I use. So I'm net zero or net positive. And I have not paid DTE for electricity in the last 3 years. They charge me fees, all kinds of fees, distribution, recovery fee, and all kinds of other fees. But for actual electricity, I have enough energy excess in the summer to build up a bank. And then in the winter, I draw off that bank. And I always run a balance in my account there. So I've not paid DTE in 3 years for electricity. So that's my story. Any
And
questions?
Yeah, it's a great story. Quick question, Michael. And this question is also directed to Diane. Who installed your solar system, Michael?
Well, my system was installed by Harvest Energy. And the reason is because our homeowners association had no idea how to handle this. And one of my neighbors contracted with Harvest, and he brought them to the board meeting, and they made a presentation at the board. And they approved it. They had restrictions. You can't do it on the front of the house if you can see it from the street, which is now illegal. Now you cannot stop somebody from putting them on the front. But when they were there, they said, by the way, if anybody else wants to get solar, we'll give you a $2,000 discount. So I signed up, and that's how I ended up with Harvest Solar.
Sounds great. Diane, who installed your system?
Distributed power, which is not operating anymore. But now this was 2.5 years ago, so it was
Right.
distributed.
That's
Yeah,
something
Brandon.
about being an early adopter. My panels were made by SunPower, and SunPower just declared bankruptcy.
Yeah.
Other questions for Michael?
Yeah, how much are your annual fees to DTE?
Oh, there may be about between $20 and $30 a month.
Really?
Okay.
Yeah.
I mean, I have solar panels in my house, and my monthly bill from DTE is $8.50. So it must be just, I don't know, the variation might be, I don't know. So
I have a question.
go ahead, Melanie.
We're in Consumers Power area, and it's my understanding that the Public Services Commission decided that they couldn't charge us a line fee, so we have no fee.
Wow.
Our monthly bill is zero. Is that not true for DTE?
No,
they
what
have
is
service
hap-
charge.
What? Go ahead,
So
Mike.
let me, I got a letter this week, and actually it was going to be breaking news at the last slide of my presentation, but in that the subject has already come up. I got an email this week from DTE that said they were reacting to the Michigan Public Law 235, and that all our credits could be used against all electrical charges. And the only thing we'd pay for is something called securitization. And I talked to DTE trying to figure out what that is, because that didn't show up on your bill. And there's a tiny line on the bill that says other volumetric charges. and it's wrapped up inside of that. So I think in the DTE area, the bills are going to go way down. And for
Wow.
instance, in Michael's situation, all his bank can be used against all those distribution charges. It's my understanding.
Yeah, that's
Well,
right.
I got
Harvey.
that same letter, and in the letter it says, we're going to do this so that we deplete your account.
Well, I didn't see that. They didn't say that in my letter, but it's going to be fascinating. So anyway, I don't know. I don't want to digress. We need to stay on the program here, but at least
But-
I thought I'd clarify that.
Yeah, but that policy also applies to consumers' energy as well. So we should see improvements as well. And GLREA actually pushed back on the exemption for securitization, but the Public Service Commission said no, the law doesn't apply to that charge. Okay, let's move on to our third panelist. David Arnosti will talk about his home in the Lansing area. David?
Thank you, John, very much. I'm just going to hit share. Let's see, PowerPoint. Let's see if this works. It's giving me a lot of questions. Just a second. I am used to using Zoom, but they keep changing things. Let's see. Share desktop. Allow Zoom Workplace to share your screen. Open system settings. Okay. Every time they update their system, I have to later. It's asking me to do a lot of things here. I'm really sorry, but it's not letting me share. Oh, wait a minute. Something just happened. It seems.
It's working now, David.
Are people seeing that? Thank you.
Yep.
Thank you, Zoom, for updating and keeping us on our toes. I'd like to, first of all, thank GLREA. Two big reasons why you should join GLREA, in my opinion. I've learned so much about renewable energy and things one can do as a homeowner from GLREA presentations. It's a valuable resource. And two, they keep us up to date on things at the state level. And in particular, I'm very interested in following what's going on with legislation supporting community solar, which we absolutely need to pass that. And I understand this fall is a time when it might be coming up for a vote. So people in diverse parts of the state, contact your legislatures and tell them to support community solar. I'm a professor of biochemistry at MSU. I've been active with our church's green team. We put solar panels on the church, and also have been active with Michigan Interfaith Power and Light, which helps houses of worship do similar renewable energy kind of things. And just a comment, coming into this maybe 15 years ago or more, the question is, why would you do solar in Michigan? We only get 1,500 kilowatt hours per square meter compared to like the Southwest. And one thing that's interesting, so 1,500 kilowatt hours per square meter of solar energy. If you look at a country like Germany, they only get 2/3 of that. And yet, if you look at summertime production, there's a graph in here showing what looks like bananas sticking out of the banana split. Those are the proportion of electrical energy generated by solar every day. From about half of that is from rooftop solar. So even a cloudy place like Germany can actually profit a lot from solar energy, and Michigan could do far more. So for our property, we're in East Lansing. We have a 1970s house. It's 2,000 square feet on a 1/3 acre. On the west side of the garage, we have solar panels, a 4 kilowatt system. On the back of the garage, we have 2 hot water panels. I have 2 small solar powered attic vent fans. And then vaguely in the backyard, you can see the remains of geothermal excavation, and I'll just mention what that is in a moment. So viewed from the street then, we don't have a historic home. It's just another suburban home. So we put up solar panels on the garage back in 2010. And this was early days. So now it's a almost 14-year-old system. Before we did that, or in the process of doing that, this old home, which had very little insulation, we took care to insulate the attic with blown-in cellulose, and we also did the walls because there was really not much insulation at all in the walls. We used something called aircrete, which is a magnesium oxide cement with a foaming agent. It comes out like shaving cream and hardens up, resists eating by insects and is fireproof and doesn't expand and doesn't give off formaldehyde like urea foam. Downside on our house is we have aluminum siding, so they had to, you can see the red arrow pointing to these little plugs where they blew it in. So that helped make the house warmer to start with, more energy efficient. The first thing that went in was 2005 with then called Urban Options, now Michigan Energy Options, I think. They had a program helping homeowners put in solar hot water. We have two south-facing panels. These run a coolant like Prestone through them, so we don't have to drain it or worry about wintertime freezing. And that's on the back of the garage. You don't see it from the street. In the basement, we have a 119-gallon tank that during the summertime gets quite warm. Heat exchangers then take the heat from the roof, put it in the water tank, and this is our hot water pretty much 6 months of the year, and then it goes into a regular hot water heater that's gas-fired that is backup for the wintertime. So we installed at that time advanced sharp panels. They were probably like 250 watts. That's much smaller than you'll get now. We included microinverters because of shading issues. And at the time, it was providing about 80% of our electricity. Our cost up front back in 2010 was $8 a watt, including new shingles. Nowadays, such a system would be $3 a watt. After 30% tax credit, you could get a system like ours for less than $10,000. So things have really changed a lot since 2010. So we got regular production also on cloudy days. You can see the system life production is 54 megawatt hours. That's about 10 years worth of electricity. And until we added a geothermal system and an electric car, that was about 80% of our power. Now that we've become more of an electric household, we're likely to be adding more solar panels to cover that extra usage. This is just a typical production for 1 year, and you can see a period in January when we had snow, so it goes to zero. I do have a roof rake. My wife doesn't let me go up on the roof, but I can stand in the driveway and shovel the snow off the solar panels, which I'll do particularly in early spring when things are about to melt.
Probably after prison, he was sent into exile, but it.
Robert,
But it's
you're
really
not
clear
muted.
that there is no
Robert
order in
Teeter,
exile, but there
you're
is. They
giving us a
overthrew it.
background sound. You probably want to mute yourself. Did you get that? Okay. So in certain cases, the microinverters needed replacing, and we rely on Matthew Cadwell's Sumter Solar Service. They've come out several times and repaired those. So in 2022, we investigated geothermal. Andre Mason, you can also mute yourself. The kinds of geothermal systems that are out there essentially all use ground heat or ground thermal mass for either heating or cooling your home. There are loop systems, good for large properties, and then there are closed loop vertical systems, which we ended up doing because we have a small property. So we ended up going with Michigan Energy Services. They surveyed our ground and said we could sink 3 boreholes in your backyard. That would provide 100, they would be 150 feet deep, There's a PVC pipe that goes down to the bottom and back up again. So it's a closed loop of circulating water methanol. And that goes into the house, into a heat pump, which extracts heat during the winter time to warm the house and serves as an air conditioner during the summer and dumps the heat back into the yard. This is what it looked like when they maneuvered the drilling rig into the backyard. These are the 3 holes that they drilled. So they're not very wide. You can see plastic tubing sticking out of them. And then the geothermal contractor trenched all the way to our house, installed connected PVC pipes so that we could circulate the heat exchange medium into the basement. This is what it looked like immediately after they had closed it up. So a big dirt patch. And this is what it looks like now. Most of it we reseeded, and then I also planted a native plant garden on part of that. So inside the house is a heat pump. It's the exact same footprint as the old gas furnace. Running into it are these insulated lines which contain the water methanol coolant that comes out of the ground at about 50 degrees. Heat is extracted, it's returned to the ground at like 45 degrees, something like that. And initially I was tracking to see how this thing worked. One big difference we noted is it was able to hold the temperature of the house very steady, and our bedrooms finally got to almost the same temperature as the downstairs. Previously, our bedrooms had been really cold compared to the rest of the house. Because of the way that it works, we were able to get a more even temperature. We went with a Hydron heat pump. This is one of the major corporations. I think it's made in Illinois. Features about it, it's got high efficiency. So Michael Hagan was talking about his heat pump, which is an air-to-air heat pump. We're a ground-to-air system. That is a higher efficiency because you're exchanging against 45 or 50 degree temperature liquid rather than whatever the outside temperatures are. So we were able to comfortably heat the house, no problem, also on the coldest winter day. And for air conditioning efficiency, it's also better than your best air-to-air air conditioner because you're not trying to dump heat into 90-degree outside temperature. You're using cool groundwater for that. The geothermal system cost us $39,000, $27,000 after the credit. We took that tax credit over 2 years. You can spread it out. That was part of the IRA legislation that makes it possible to put in this kind of equipment. And of course, our gas use drastically dropped off. We just use marginal amounts for heating hot water. And our electricity went up, and I'm still trying to figure out like what was the balance in terms of savings on gas and paying more on electricity. So for finding the geothermal contractor, we used this stateside website called Earth Comfort. There's a Michigan Geothermal Energy Association, and contractors put their information in there and describe how you can contact them. We also added an EV in 2022. This is adding to our electric bill. So this gets driven about 6,000 miles a year, which is about 1,500 kilowatt hours, or about what would be equivalent to 3 months of our household use beforehand. So I think that we will, once we've assessed how much more electricity we use for the geothermal plus the car, then we'll be adding more panels. And we put a level 2 charger in the garage just to accommodate that so that one can charge the car conveniently at home. So that's, we're not quite where Michael Hagan is, but we're working on it. I think our next step will be putting in a heat pump hot water heater and finally telling Consumers Energy that we don't need their gas anymore. Thank you, everybody. I'll be happy to take any questions after we've had our next talk.
Do we have any quick questions for David? Just a quick one.
Yeah, I have a quick one. You talked about shoveling with snow off the panels with a rake. How does that work? And if you don't shovel it off, how soon does the snow dissipate?
Oh, okay. So it's called a roof rake. You can get them at hardware stores. This is for Yoopers, a well-known product to keep your roof from collapsing when you get 6 feet of snow. It's essentially a plastic shovel with a long handle on it, and you just pull it down. So it's not actually shaped like a rake. It looks more like a shovel. And I generally do that if we've had a good amount of snow and the temperatures are above freezing. So you get it started and you pull on the snow and then it slides off the panels. So it's best to do that, early in the year when you're getting a lot of sun and you really wish that that latest snowfall weren't sitting on the panels. They're available at all hardware stores, and you can, I think somebody's put a link into the chat.
Yeah,
I
that's
get, yeah, I get commentaries from the neighbors sometimes.
sounds
You're
great.
shoveling your roof again.
Okay, well, thank you very much, David. Great presentation. Let's go to our last presenter, Harvey Bell.
Thank you. Hopefully everybody can hear me.
Yep.
Okay. Get this in the presentation mode here. Okay, it should pop up here in a second. It takes its time to get to the presentation mode. So my wife and I were, as we aged, we were faced with a problem. Our house, we needed to find a new place to live because our house had some structural problems, think black mold, a bunch of things. And after much working, we decided we'd tear our house down and build a new one. And discussion started, my wife said, over my dead body. But fundamentally, we needed to build a home that we could thrive in. We wanted to have low operating costs, low energy consumption. That meant if we wanted a home for the future generations to thrive on, meant we needed to do renewable energy. So this is a home we tore down. We've actually lived on this lot for 35 years, and this is the result. We've got 47 solar panels at 450 watts, just about 20 kW. And so fundamentally, we wanted it sustainable for future generations. So we wanted to minimize our energy use. We want to minimize water consumption. And we've got rain gardens, and we retain the water that runs off the roof in cisterns that we can then water the garden with. And we wanted to generate no landfill during the tear down. So we hired a company, Architectural Salvage in Detroit, to tear down our house and resell everything. The house was designed to meet FIAS, it's the Passive House Institute of US 2021 standard. We were the first house in the nation design certified, and the second house to be completely certified, final certification. Very, very well insulated. Think R51 for walls and 120 for the ceiling. Very airtight, vapor barrier, and we have really a net positive house. The architectural firm was Architecture Resource out of Ann Arbor, Michael Clement. Fireside Home Construction did the construction. So we had to name our house for FIAS, and we called it A Pleasant Future Vision, sort of a little quirky because we live on Pleasant Street. And it's a complete electrical home with all Energy Star appliances. I'm not going to read everything on this slide. My wife in her first career was a physical therapist. So, everything is set in place to age in place, and so that we don't trip or fall or anything like that. We wanted to ensure that we had healthy indoor environment. We monitor the air. And so we've got just over 20 kW solar panels, 45 kilowatt hours of simplified batteries that are lithium ferrous phosphate. And with DTE, we've got a time of use plan called dynamic peak pricing that is very advantageous. Here's an aerial drone shot of the roof with the panels. When Michael Clement came and looked at the house that we tore down, he's sort of interesting fellow. He got on the roof. This is just the beginning of COVID in a complete hazmat suit with all this instrumentation to measure everything. And he said he'd never, ever measured a better urban setting. And my wife said, well, you probably say that to all the girls. But anyway, here's the batteries. There are 12 simplified lithium ferrous phosphate. Simplify has since been bought by Briggs and Stratton, and they're now branded as Briggs and Stratton Energy. Everything, our heat pumps, we actually have exactly the same set of heat pumps that Michael Hagan has. I've got 3 of them, one for each floor. We've got a hot water, heat pump hot water heater that's programmable for time of day use, and Energy Star appliances everywhere else. And the heat pumps, the HVAC are also, I can set a program on those. We maintain all the stormwater on the property. Insight Design Studios in Ann Arbor did that. And we also have a hot water recirculation loop to minimize our you don't have to run the water to let it get warm. And EPA WaterSense fixtures. You can see we ended up meeting a lot of standards, the EPA Air Indoor Plus, the Energy Star certification. Our HERS score came out at -20, exceedingly airtight in terms of for a blower door test at 50 pascals. We ended up at 0.23 air exchanges per hour. Here is, you can see the HERS in more detail. Then another look. And then Zero Energy Ready for the Department of Energy. We were awarded a Housing Innovation Award by the Department of Energy for one of the 2024 awards. So our indoor air quality, I monitor continually. I've got 6 different sensors. The heart of the solar system is a Solar 15K inverter. I'm going to talk to you more about that. We have, like Michael, ERV, which is Zender. And then we also monitor the humidity in the walls. The architects were somewhat concerned in that we're going to try and maintain the home at 45% humidity. So in terms of my philosophy and what can happen, during the summer, I use the batteries at night. And then all the major loads I try to run during the day and charge the batteries. During the winter, just like Diane, charge the batteries at night and then power the home from the batteries and photovoltaic during the day. Here's a picture, another picture. This is a Solar 15, which is really the heart of the system. It's got amazing capabilities. One of the things that the Solar can do is it has a time of use capability such that you can set 6 different times. And this is actually a screenshot from their homeowner's book that tells you how to set the settings up. And you can determine how much you want to charge the batteries, or you can see there's a column that you can say you're going to charge the batteries or you're going to sell to the utility. The flexibility that this inverter has is really substantial. It's actually 2 inverters. It goes from the DC to 120/60 to power the home, and then a second inverter that goes from 120/60 to 48 to 56 volts DC to charge the batteries. Really, I couldn't run the home in the manner that I'm running it right now without the flexibility of this Solarc. Solarc is a company operating, a relatively new company operating out of Texas. Really great product support. Here's a sort of a screenshot of what my web shop looks like, and you can actually see the shot here that what's going on. I'm going to stop sharing at the moment and go show you real time and share a different screen. I'm going to share that. I'm going to actually show you what's happening in the
Harvey,
panel right now.
It didn't stick.
Yeah, I recognize that. It's about to stick now, I hope. No. Well, hang on one second. Okay. There we go. Okay, it should be sticking, and you should actually be looking real time at what's going on. The house is using 900 watts right now, and we're getting 945 watts from the battery. Down below, you can see what happened during the day. The great big green arc, hopefully everybody can see this, is 36 solar panels. The light blue arc, I'll turn some of these off. So now if you sum those two arcs up at 1250 today, I was making about 15.2 kilowatts. Now, if you look at the loads during the day, you can see right here, I charged the solar car, I charged my electric vehicle, and then the batteries got charged. And then the yellow graph is where I'm selling power to DTE. And so then if you look, here's what happens if you look at just DTE today. This is what happened. You know, this is where I charged the battery during the night. I sold power during the day. Here's what has happened so far in October. The green bars are where I'm selling power to DTE. The red bars are where I bought power from DTE. Here's at a by a month basis. And just like everybody mentioned, January, it was cold. And there was a lot of snow on my solar panels. And I bought a lot of power. But that'll give you an idea. And if you look at over the 2 years, I'm net positive. And right now in DTE's bank, I've got about $650 in there. And so, you know, from that, it's pretty good from, you know, where I'm ending up overall on a monetary basis at the moment. But we'll go back to the presentation here. So you get a sense, and then so out of if you look at what the Department of Energy says, as they went through all the data for the award, this will give you a sense for what they computed our savings and with PV for 30 years, the savings they would suggest would be $503,000. So that's their view. before, this new change with DTE, our energy bill over the last year was $650. And as I said, breaking news that that I got today or earlier in the week was that all the outflow will apply to everything except securitization. Trying to guess at how much that's going to be. I think for a total year, my energy costs are going to be about $25. So thanks to GLRE and all the other people that worked for the state of Michigan to make this happen. I think that's really a substantial achievement that those of us who got solar are really going to be in the capability to do that. Pretty substantial, I think. So if you've got questions, I'll be happy to answer.
Thank you very much, Harvey. Excellent presentation. Questions for Harvey or for anybody else of our other three panelists? Well, I have a question for Harvey. How much you built a house from scratch and you had the forethought of building all these incredible systems into your house, whether it's water conservation and everything. Is your background, are you seeped in all this and you knew exactly what you wanted to do, or you just were able to approach some people who gave you ideas on what you ought to think about?
Well, a little bit of both. I mean, there's a lot of stuff that I ended up learning on the fly. I started thinking I was going to do a geothermal. I'd always wanted a really energy efficient house. Now, I'm an engineer. I flunked retirement. I'm on the faculty at Michigan. But part of it, it all worked in a lot of different ways through the process. But I'm used to putting complex systems together, and I went in making sure that I didn't want to do things twice. So I did a lot of research at the same time along the way.
The same question I'm going to ask Michael as well, or in fact, all four of you. I mean, you all seem very innovative in your thinking. I mean, for someone who doesn't have a background in engineering, it can be kind of intimidating when we see people like the four of you. So what pearls of wisdom would you share with people that are thinking about going down this road?
I'll answer that. My background is I'm a retired physician, emergency physician. So this was not my bailiwick. And I just learned it, being interested in it, and then just doing a lot of research and finding out. And, you just learn things along the way. You find out different companies, different people, and you just grow.
David,
I
you
can
had your hand
also
up.
answer that. So the ASES periodical Solar Today has been a useful source of information for me. And I would say for anyone who's thinking about such a system, having a reliable and ethical contractor is so critical. So for a number of recent installations in the Lansing area, we've worked with Absolute Solar, a local firm, and they have been a very good source of information and also have worked closely with all kinds of private, nonprofit, commercial clients to get the job done. So asking around and getting recommendations for contractors and interviewing them, just like you would for somebody putting on a roof or whatever, is really very useful.
Harvey, who installed your solar system?
John Wakeman, and he's been he was at the GLRE conference in December last year. He's been connected with you guys on and off. His business is SureBiz. He's out of Ann Arbor. A great guy. He's been doing it for years. I would also say Michael Clement out of Architectural Resource in Ann Arbor. you know, we started down this path. He has done a number of net zero homes. And then I ask questions, and not unlike Michael, you got to ask a lot of questions and get and work with really good people. And I think John Wakeman, Michael Clement, and then Fireside Home Construction, it did a home, Burback home with Michael Clement that is a living building challenge home. And the last I knew, there are only 2 of those in the nation. And living Burback is outside of Dexter. And so a lot of very knowledgeable people to get involved with there that and then you start working with those people and ask a lot of questions and want to make sure you get it set up right to begin with.
Okay, we have time for one more question from Kenneth. Kenneth, why don't you articulate it out loud rather than me reading it from the chat?
Okay. Well, I started thinking about the situation around, here in this group, we have very smart people who have implemented, and maybe the cost went up to implement it. Maybe the efficiency went up, but maybe it didn't. So I'm kind of like in the dark about. I used to think, oh, it's more efficient today, but maybe it is, maybe it isn't. If you had to do it today, I guess, would it be the same efficiency or better, or?
It would be more efficient today, but not that much. The cost is the difference. My first solar system I put on an apartment building, and I didn't get to answer how my experience, but thanks to Bob Tinker and others, I learned that you just have to ask enough people what you're doing. And I have a apartment building with Cylindra solar tubes on it from 2009, if you can remember that name. But that costs about $6 a watt back then. So now the costs per watt is just so much lower. So your cost, you're able to add things like the batteries now. So I'd say the batteries have been the game changer for most systems. If you could even put in a small battery, at least you're getting that backup power, and the ability to sell back to DTE is what's making it a lot more affordable now for people.
I actually
have a
saw,
follow-up. Sorry.
there's one more question, and that's for Harvey from Clyde Taylor. Clyde wanted to know whether Harvey's roof is standing seam steel. And I'm not sure what that means, but hopefully, Harvey, you do.
Yes, I do. And yes, it is. And that's how you attach solar panels most effectively to make sure you don't get penetrations. And it's a steel roof. The steep pitches are actually at 1412. Snow doesn't stay there. The lower pitch is 12.2, and that accumulates snow. And I've got a snow broom that I can actually push the snow off sort of out the window. I'm busily trying to create a way to have a cover that I can slide on and off, not automatically, it'd be manual labor, but I'm going to solve that problem. I'm in full invention mode right now.
Small copper wires that can heat up. That's what my husband keeps saying. We've got to figure out.
Oh, I didn't want to use any energy.
Well, using the electricity from the solar, we could wire something up there because we have the same issue.
I'm happy to call that heat tape. Used to call those things heat tape in the old days.
Yeah, they still do. Keep snow out of gutters.
Okay, well, this has been absolutely wonderful. We've passed our time. So I just want to thank all of our presenters, Diane, Michael, David, and Harvey. Excellent presentations. And I want to thank all of our participants for joining us this evening. And we're recording this. We're going to put it on our YouTube channel. And if any of you are not GLREA members, I would encourage all of you to join. And once again, I want to thank ACES for being our partner on the solar home tours, as well as our sponsors. So have a wonderful evening, everybody, and look to the weekly updates for the next solar story or renewable energy seminar. Bye-bye now.